Hello, everybody. Nice to meet you on this session. Do you think about dismissal? Maybe do you worry about dismissal? Please raise a hand who right now consider their offer from are considering the offer from some other company, or maybe think that their idea to change company, to leave your current company, it's not too bad. Oh, okay, I can see someone, but we can see that there are a lot of very polite employees in this audience. So right now we have a very good news for you, because we today will present you our solution in the context of assessment dismissal risk for every employee who are right now working at company. Assess the risk that this employee will leave company soon in some nearest time. And I would like to start from our motivation to this project. Actually, employee turnover is a very significant problem for many companies that are related to the different business domains. And the severity of this problem increases in the case if we are talking about some large company, especially in the case of their continued growth. Employee dismissal results in additional expenses for the company, which are definitely connected with the necessity to find and hire some new specialists. That's why it's very important to understand the reasons of employee turnover and understand which employees are at risk of the dismissal. This information will be very useful for the management because they could take this information into account and could take some preventive action in the context of employee retention. That is the reason why a lot of companies are interested in the implementation of such solution of the employee dismissal analytics tool. Because they suppose that this tool allows them, provide them possibility to somehow highlight the most important reasons of employee turnover, highlight the drivers of employee dismissal in one or other case, and they allow them to take them into account, and as a result decrease the company attrition rate. A couple words about the reasons of employee turnover. Actually, we could divide them into two groups: some outer or objective reason and inner or subjective reason. Outer reason, reason that could be reflected, we can find some indicators of this reason in HR systems, and we can extract these indicators from employee historical data. As for subjective reasons or inner reasons, we can state that we do not have any objective evidence for the case of subjective reasons. And the only options to get some indicators, it's from maybe interview with employee or colleague of this employee, and maybe from some regular survey if in one or other company have there is the same tradition to provide the regular survey for employees. So, as for inner or subjective turnover reasons, we can define the top 4 subjective turnover reasons according to various researches. First of all, it's fail to connect with the bosses as leaders and people. Also, some reasons related to the work environment, when employee considers that work environment like unfriendly. Also, the most important, very significant reason when employees do not feel appreciated. And one more reason, when managers will not listen to employee. These things are very hard to be discovered, actually. Objective reason. Very likely we can extract some indicators of this reason from companies' data, from different from HR systems. We can extract this information from employee history. First of all, it's some kind of work-life imbalance. Actually, we could extract this information from different control systems. For instance, if employee has a lot of overtimes or there are some problems with vacation, it could be considered like there is some work-life imbalance for this particular employee. Next one, it's a situation where job did not meet some expectation. For instance, we can compare some description of project and employee position. And in the case when a job description project doesn't match to employee position, it could be considered like situation where job did not meet the expectation. Next is affairs and confidence shaking. Actually, we could extract this information from performance appraisal. We could use some feedbacks that employee get from managers or from his colleagues or from career advisor. Next one, it's when situation with coaching and feedback are lacking. So employee do not get any feedback from managers, from maybe colleagues, and employee do not feel that his contribution is appreciated. Next, it's rises and promotion frozen. Of course, we can get this information from employee history data, and growth opportunities are not available. All of these reasons can have some indicators, have some markers in historical data that are gathered in company databases. So we started to work on solving this problem, on the development of the systems that allows to predict if one or other employee leave company in the nearest future. And we defined the following goals of this project. First of all, it's identification employees who likely to leave the company in the nearest 2 or 3 months based on employee historical data analysis. Next one, it's a definition severity group for employees that are at risk. Next one, it's a providing basis for the assessment of risk, for assessed risk explanation. And finally, highlight objective reasons of employee turnover. A bit word about data sources.
Okay, data. What data we need or data we can use? Always this is the main question for us. And in this project, we had a big problem with the list of data sources, security issues, and for the first stage, we selected the next sources with historical information about our employee, which we can extract from HR systems and internal data warehouse. Some explanation about our data sources. Firstly, professional information, personal information about employee, compensation history, performance appraisal history, project relation information, included project profitability, business trip history, vacations, day off, and certification history. Okay, modeling stages. For this project, we use the next scheme, and I think a lot of us uses a similar flow in any data science project, as this is very closest to any project. Firstly, we made data analysis stage for researching patterns in data with the target variable. After, we were doing feature engineering stage using results of data analysis stage, and after this we can prepare the dataset for a model, and the next stage is very important and interesting. This is building and tuning a model. In the end, we need to provide some interpretation results for business and our interpretation of our results, and we selected for this stage dismissal risk zones. Okay, Tanya?
Okay. According to our research stages, we started from the dismissal drivers analysis. Actually, we defined several, according to the analysis result, we defined several, the most important factors, the most important features that could be considered like drivers of employee dismissal. And the first pair are related to the compensation. In this case, we consider it two features like wage and wage rate. What does it mean wage rate? It's a coefficient that reflects how many times salary of employee differ from the average salary according to the market situation with respect of employee level and employee competence group. Employee competence group for instance, Java developer, Python developer, data architect, data analyst, etc. As for employee level, we are talking about junior, middle, senior, lead, expert, etc. In our case, we consider it three specialist level group like junior, middle, and senior. On this box plot, blue box plot related to the employee who decided to continue to work for this company, and orange box plot related to the employee who decided to leave company. So, according to the analysis, we got the following results. It's enough interesting because employees who leave company during 3 first years are characterized by low compensation low compensation in their level group. Please keep in mind that in this case we do not divide employee to the competence group. We just consider the level group like senior, middle, and junior. You can see that the difference between average salary of the employees who decided to leave company and who decided to stay working for this company, that increases in the case when increase their specialist level. So for senior level specialists, this divergence is much more significant than for the junior level specialists. As for wage rate, we can see that senior level employees who leave company during 3 years are characterized by low compensation rate in the comparison with the average market salary. Actually, the same situation the situation with middle-level specialist also can be considered like the situation with senior, but for the junior, this pattern is broken. But in any case, we can state that wage and wage rate have a very good correlation with the employee dismissal risk, because the higher compensation level of compensation and the higher wage rate, the low risk we should expect. Next two drivers are related to the promotion. In this case, we consider two types of promotions. First one related to the salary, and second one related to the position. Months on salary and months on the position. It's a period when employees have the same salary or continue to work on the same position, so without any promotion, without any salary rise. So we can see that there are some pretty light dependency for employees of junior, middle, and senior levels in the context of months on salary and months on position. The longer employee on the same position or the longer employee on the same salary, the higher risk of his dismissal. Next, two are related to the employee load on the project and the feedback that employee got from managers and from career advisor, from his colleagues. So we can see that employees who decided to leave company, and this employee from the junior, middle, and senior level of the severity, are characterized by less % of contribution to the project than the employee who decided to continue to work for this company. Evaluation score related to the feedback that employee gets from managers or from colleagues. And it's interesting fact that employee who gets a pretty high evaluation score, more than 86%, for this group, only less than 10% of employee decided to leave the company. But if employee gets a low evaluation score, less than 74%, the dismissal risk is increased from about 7% to more than 25%. And finally, it's some indicators. It's somehow connected with work-life balance. Actually, we didn't have an information about overtimes, employee overtimes. So the only indicator that we could use, it was a vacation. Actually, we can state that there is some significant dependency between vacation and risk of employee dismissal, but there is pretty interesting fact. Employees who haven't been on the vacation more than 6 months are more willing to leave the company. So let me summarize. We defined 5 dismissal drivers: compensation, promotion, load, feedback, and vacation. The low wage or the low wage rate, the high risk of dismissal, the high period without promotion and the with any promotion in terms of salary or in terms of position, the high risk of dismission. The less employee contribution to the project, we also can see that in this case, risk of dismissal will be high, will be more high in the than in the other case. The worse feedback from management, the high risk of dismissal, and finally some conclusions regarding vacation. So. Next, it's the features and data sets.
Okay, so everything begins with the preparation of dataset. Before you start building a model, you can predict the risk of dismissal of an employee. You need to prepare data on which our model can be trained. Each employee is described by a set of characteristics, a feature vector, and each feature vector is assigned a flag indication whether the employee left company or no. How we did this stage? How we did describe an employee? We described an employee using next features. Firstly, demographic information according to the last month's situation. For example, age, gender, marital status. Next, position information, competency, direction, management level, position, location, English level, time on position, time in job profile. Next, financial data according to the last month's data. For example, some statistics of wage and wage rate in the corresponding competency and manager level group, and time on salary. Next, performance data. We use some KPIs about performance in project. Next, project-related info according to the last month situation. For example, last project features, number of projects, and information about these projects. In the next, some other source. We aggregated information from this other source. For example, features-based features which describe business trips and certification history of an employee. Moreover, we need to describe categorical variables, for example, projects, line manager, dev center, etc. And in this case, one-hot coding is not a good idea for us because our solution must work with new values in categorical variables. For example, we have new manager on project, or maybe company has new project, etc. And one-hot coding doesn't work in this case. And our solution, we need to describe categorical variables and values of categorical variables in other features. And for this, we're using next. We're using statistic based on KPI metrics, for example, minimum, maximum, mean, median, STD, etc., dismissal rate, and some employee statistic. And in the finish, we obtained feature vectors with more than 240 composite features. Okay, features are ready. Next stage and next question, how we need to build a dataset for a model. And for this problem, we can interpret our data as a time series and apply window approach to building this dataset. Okay, in this case, we can calculate a feature vector in 3, 6, and 9 months window. Moreover, we define a target variable for 2 and 3 months risk dismissal. 3 months is our main goal, but we need to provide a good prediction in the first part of our prediction period. And for this, we add 2 months target. In the finish, we apply a rolling window and with padding in 1 month and creating 8 data sets for a model. As you can see, we selected 6 months in data with target on next 3 months. After we apply 1 month padding, selected next 6 months, and calculated feature vector and applying concatenate all these feature vectors in data set for a model. Some kind of visualization. Visualization is the most important process in our work. As you remember it, the first yesterday's speaker, we need to think carefully about it. And for example, for you, we proposed this linear representation of our dataset. As you can see on this plot, on this visualization, we don't have good clusters, but we can recognize some structures and zones with and without dismissal risk. But keep in mind, this is only linear projection, and we can't make any clear conclusion about the structure of dataset. Red points on this visualization, employee who leave the company, and green who is still working. Please keep in mind it. Okay, next stage, model training.
Model training. So we're starting from feature engineering, and we got a lot of features, more than 240 features, and we got 8 data sets for the different period of historical data, for the different forecasting period for our target, and with some other conditions. So we started to the next stage. It's starting training and selection the most optimal model. So our first stage was related to the attempt to find some basic model, some baseline model that we will use in our further analysis, and then we will try to adjust to find the most optimal solution with taking into account this particular basic model. So we considered a lot of models, and this it's a very short list of these models, like logistic regression, random forest, multi-layer perceptron. Actually, this is the so-called list of winners of this model. They provide us in the first approximation 72% accuracy on cross-validation, but when we try to use model which is based on gradient descent boosting trees, for this purpose we use the LightGBM library from Microsoft. It provides us in the first approximation accuracy of 78%. So we decided to start working with this particular model in our further research. Actually, we are starting to solve the problem of the assessment of likelihood of employee dismissal as a classification problem, and trained a LightGBM classifier for all our data set. Despite the fact that we had 8 data sets, so this data set, the result of this model, had some similar characteristics, and they showed the similar behavior in terms of different data sets that characterized by different lengths of historical data. So just now we consider some average characteristics that we got from all data or all model that were based on the data set with 3 months historical data, 6 months historical data, and 9 months historical data. So what result we get? First of all, we can state that its result is satisfied, that is good result, because 3 months model could be considered like more the very strict model. On the other hand, this model provides us to find almost all employees who potentially will leave the company. But on the other hand, this model characterized is very low precision. So we have a lot of false positive reactions. As for model for 6 and 9 months, we may see that the precision for this model much higher as for the model that is based on 3 months length historical data, but with the recall is too small. Actually, for 9 months based model, we lost 30% of employee who potentially will leave company. It's not very good result for us. For this purpose, we try to use some other type of models with some kind of loss functions. And so that we try to solve this problem, the assessment of likelihood that employee leave company, like a regression problem. In this case, we also got several 8 models, and they have some similar patterns. So, model that was based on the 3 months historical data length characterized much higher precision than in the classifier, but it lost the recall. 6 months model characterized by 78% of precision and pretty similar percent of recall, and 9 months model, it also may be more tolerant than the rest models. So we try to combine these models into ensemble and assess the final score like a weighted average of the scores that we got from classifier and regressor. And here is the result of this attempt. So in all cases, we got the result that much better than in the case of the single classifier or single regressor. But we could see that all of these solutions also have some advantages and have some weak points. So finally, we decided to combine all of this model into ensemble and provide the final solution based on the model weighting. In any case, when we combine classifier and regressor as an ensemble, it allows us to reach 80% of accuracy on cross-validation. Next stage, it's a hyperparameters tuning.
Okay, tuning machine learning hyperparameters is a tedious yet crucial task, but as the performance of an algorithm can be highly dependent on the choice of hyperparameters, manual tuning takes time away from important steps of the machine learning pipeline like feature engineering and interpretation results. But we need carefully think about validation and metrics for optimization. This is fully depends on business requirements and inputs. And the main ideas and constraints for our model from business is next. The model has to recognize as more true positive and true negative cases as it can. True in case if an employee is dismissed in the next 3 months. We need accuracy the better as we can. The model shouldn't predict a big amount of false negative because we can predict a lot of employees as dismissal risk. And the next, the model should predict well for the future after learning on cross-validation with respect of historical data. And based on requirements for a model, we selected 2 levels of validation. First level, cross-validation, and second level, validation set the next month after cross-validation. And our scheme of tuning hyperparameters. For our tuning, we defined next parameters. Firstly, the main hyperparameters of LightGBM model, for example, learning rate, bagging fraction, feature fraction, max depth, etc., and threshold for defining classes based on a score output from LightGBM model. For tuning these parameters, we applied minimization of metric, defined as geometric average F-beta matrix on cross-validation and validation data. And the beta parameter we define it equal to 2.5. Nextly, we need to tune classifier regression weight in assembler, and for tuning this weight, we applied minimization of metric defined as the geometric average accuracy on cross-validation and validation data, and all hyperparameter tuning was provided by HyperOpt library. And in the end, after hyperparameters tuning, we obtained 8 ensembles. And in the finish, we defined the final model and prediction by voting of 8 ensembles. And our increasing equal 87% of accuracy in the finish.
A couple words. I do not think that we have enough time. About detection, so-called risk zones of employees who are at the risk zones, who are at risk. For this purpose, in order to define this risk zone severity, we performed their analysis of the ensemble final performance for the case when risk zone of dismissal is determined by their voting result. So we use the rule, if n or more models voted to recognize employee as employee at risk, we should consider him as at risk. So right now we consider several results of applying of this rule: 3 and more model, 4 and more, 5 and more, 6 and more, and 7 and more. In this case, you can see some extreme result. First one, it's a 3 and more, and the last 7 and more. First result, 3 and more, provide us very good recall. So we lost only 9% of employees who left company, but precision is can be considered less satisfying. But our first rule, our first criterion that we could meet, it's a find as more employee that will leave company as we can. The last case provide us precision with 90%. It means that we predict employee like employee at risk, that employee will leave company with 90% probability, and it allows us to meet our second criterion: provide information about employee who leave company with high confidence. So for this purpose, we consider this result in order to define high-risk zone. High-risk zone characterized by 90% of probability that employee leave company, and it contains 68% of employee who definitely leave company. Next one, it's definition of medium risk group. In order to define medium risk group, we consider the rule 5 and 6 model voted to put employee to the risk group. This group is characterized by 49 probabilities that employee leave company, and it contains 12% of employee who definitely leave company. And finally, it's low risk group. This group is characterized by 31% of probabilities that employee leave company, and it contains 11% of all employees who definitely will leave company in the nearest future. That's a distribution of final score that provide our model. In the case with employee not at risk, final score will be from 0 to 0.5, and for the first, second, and third risk group, this score is distributed more or less uniformly. Next, it's interpretation and prescriptive analytic, the last actually slide. We provide some basic for interpretation and prescriptive analytics. First one, it's interpretation. So if employee is under the risk, especially if employee is a high-risk group, we analyze their features from this employee and provide some kind of interpretation. For instance, employee in reserve, employee was not promoted too long, or employee load is too small. Next one, it's a stage of what-if analysis. What if salary will be increased? What if employee will be promoted? And after that, we can assess if risk of employee dismissal will decrease in case we increase salary or employee will be promoted. And finally, it's a final result. Salary should be increased on the person. So that's our conclusion, and thank you for your attention.